Alright, in this video we're going to continue 9.6. So let's review how we learned how to identify each conic section. So parabolas, I said, were the easiest to identify because parabolas only have one squared variable. Okay, for the other three, remember that this only applies if the x squared and the y squared are on the same side of the equation. So if they're not on the same side, make sure you move one of them so they're on the same side. Okay, so hyperbolas, the way you identify those is x squared and y squared have opposite signs. Okay, for circles and ellipses, they have the same sign, but for an ellipse, x squared and y squared have different coefficients. So for example, if one of them says 3x squared and the other one might be 5y squared, that's an ellipse. So have different coefficients. And circles, x squared and y squared have the same coefficient. Now the book teaches a different way to do it, but I think this way is much easier and it doesn't involve having to do any math. Alright, so for numbers 1 through 6, we're just going to look at the equation. We don't have to write it in standard form. We're just going to write what it is. So looking at number 1, we could tell right away it's a circle. So it's not a parabola because x squared and y squared are both squared. It's not a hyperbola because there's a plus, and they both have a 6 in front, so that makes it a circle. Okay, number 2, positive 4x squared, negative y squared, because one's subtraction, that makes it a hyperbola. Okay, so again, only look at the squared terms. Okay, they're both squared. It's not a parabola. It's plus, so it's not a hyperbola. They don't have the same number, so this is an ellipse. Okay, number 4, similar to number 1. They both have the same coefficient, and it's positive, and they're both squared. This is a circle. Alright, for number 5, notice y is not squared, so this is a parabola. So parabolas, only one of them is squared. For number 6, we have a positive 4y squared and a negative 36x squared. One's positive, one's negative, so this is a hyperbola. Okay, on number 7, we know this is a hyperbola because they say hyperbolic orbit. It also has lines that it gets closer and closer to, but it never touches, which means that's an asymptote, and hyperbolas were the only conics that had asymptotes. So we have to write an equation, and we know the center is at 0, 0. So remember the formulas. When it's at 0, 0, it's either x squared minus y squared equals 1, and then with denominators, or y squared minus x squared equals 1. Alright, so are we told whether it's horizontal or vertical? Well, the other clue that we're given is there's a vertex at 5, 0. So if you picture the origin, and then there's a vertex here, that means it has to be horizontal, because that's to the right of the center. So we're going to use the first formula that I wrote, and we just have to figure out the denominators. Okay, so we're going to have to work backwards. In the past, we had the equation, and then we found the asymptotes. Now we're given the asymptote, but we don't have the equation. So how did we find the asymptotes? Well, we took the square root of this number, and that one in the numerator, because slope is rise over run, and rise is the y, and then on the bottom was the square root of that number. So underneath the y squared should be a 4, and underneath the x squared should be a 25. So again, underneath y squared is 4, and we know that because if we take the square root of 4, we get 2, and underneath the x squared should be a 25, because if you take the square root of that, you get 5. So let's write it again. X squared over 25 minus y squared over 4 equals 1. Okay, and for the last problem, we have an ink blot covering one number, it looks like, and we're told it's a circle. Remember that circles have the same coefficient for x squared and y squared. So if this is 7x squared, then this needs to be 7y squared. So the question is, what number is being covered? The answer is 7. Okay, that's it for 9.6.